So thank you all for coming. This is PC50, using instrumentation and troubleshooting to develop high-quality software. My name is Ricky. I'm a program manager on the Windows Fundamentals team, which is part of the Core Operating System division. I'm here with Kevin, who also is a program manager in the Windows Fundamentals team. So before we begin, I thought we would sort of address why we have this particular session. And in part, it's because Kevin and I wanted a trip to Los Angeles. But it's also because Steven Sinofsky in his keynote today mentioned Windows fundamentals. And really the mission of our division is to improve those fundamentals of Windows and to drive that through the ecosystem. It's also to address something that we can sometimes overlook. So as developers, we're always pushing the envelope, innovating, creating new things to positively impact our customers. But sometimes we can forget what happens after we actually ship our software. If a customer experiences a problem, how do they resolve it? How do they get back on track? If they have to call a help desk or customer support, what tools do these professionals have at their disposal to help the customer? And so today, Kevin and I will highlight two Windows technologies that we can leverage to address this post-deployment scenario. Specifically, I will start by giving a brief background as to why Windows is investing in the instrumentation and troubleshooting platform. I will then hand it off to Kevin, who will introduce the event and performance counter infrastructures. He will highlight some of the improvements we have made in Windows 7. And then finally, some design principles that you can use when you develop your applications. I will come back, and I will introduce the new for Windows 7 troubleshooting platform. I will highlight some of the key features, briefly go over the architecture, and then discuss how you can leverage this troubleshooting platform to resolve customer problems. So, as developers, we all know what happens when we ship software that doesn't meet our users' expectations. Down the road, they may not buy subsequent releases of our software. They may not use our service. And from a cost standpoint, we have increased support volume, which leads to lower profits. So when we looked at all the calls coming into Windows and tried to isolate and bucketize these problems, we sort of came up with two high-level buckets that Kevin and I will talk about today. The first is design issues. This includes code bugs, but it can also include purposeful design decisions that lead to functionality that a user may not expect. And the second bucket is configuration conflict. And this is where the state of the system isn't in a condition where our application can run successfully. And so let me give you an example here. I have two applications on my machine. One requires the firewall to be enabled. The other requires it to be disabled. And if I'm trying to run both applications at the same time, it's not a bug with either of these applications. It's just that the state of the system isn't conducive to one of those applications running successfully. So as an ecosystem, how do we actually address these problems? Well, given the diversity, given the diversity, it's important that we actually address this in a structured way. If Kevin develops some software, and I develop some software, and it runs on the same platform, why should we have the administrator use different tools to troubleshoot our separate software applications? And the benefit also is that when we're actually developing this, we don't have to reinvent the wheel, so we can ship the software out faster. So to that end, we have two platforms that we will highlight today. First, the instrumentation platform. Then I'll come back and talk about the troubleshooting platform. So with that, I will hand it off to Kevin, who will introduce the instrumentation platform.
Thank you, Ricky. So if you're anything like me, when you start writing code, you start writing your code, you start developing, and you realize, oh, there's a problem. Something's not behaving the way it should. First thing I do, I put in printfs. I'll admit it. Well, and that evolution continues. So I put in some printfs, and I put in some printfs, and I decide, oh, wait, I want somebody to use my code. So I hand it off to them. But I need to disable those printfs that I put in. So I might develop a library to wrap around those printfs. So now I have a library that I've built to help me diagnose a problem. It's shipping with my code, and I can turn it on and off. I might need to recompile to do that, but it's my own thing. Now, you may work on a team, and that team has developed that similar sort of library. That library of code that says, okay, if you are developing and you need to put you need some information out of your application, you use this library. But that's now, you've rolled that on for your own company. If somebody is trying to diagnose a problem with your software, they have to know your specific platform. They have to know how to turn on and off your instrumentation. And it doesn't play with anybody else. So it doesn't work in an ecosystem. If we're trying to enable ourselves as developers and the people who use our software, the IT admins and the IT pros, if we're trying to help them actually diagnose and debug their problems with our software, we need to standardize on a platform. We need something that's easy to use from their perspective, but also easy to use from our perspective as developers. We hope to provide that. We do provide that with the Windows Instrumentation platform. Today I'm going to talk about events and performance counters and the proper way to use them, what we have available in Vista and in Windows 7, and how we've made it easier to use as a developer to author that instrumentation. The first thing that I want to highlight here is that instrumentation, the entire goal here is to expose the internals of our application to somebody else. And the goal in Windows is to do that in a way that's discoverable, meaning somebody who doesn't know anything about your application can find your instrumentation and find out what events, what counters it raises, and then do something meaningful with them. We want it to be easily consumed, and to make it easily consumed, part of that is standardization, having a standard set of tools, a standard set of APIs to actually do the consumption. The purpose of all of this is to diagnose and debug problems when you really get down to it. But also there's an aspect of this which is really centered around manageability. How does somebody who is deploying your application actually figure out how to manage it based on that instrumentation? When we think of ourselves as developers, what we do oftentimes is use instrumentation to trace the actions of our application. Did it enter this function? Did it exit this function? Oftentimes we use it for performance analysis, for placing a start event and a stop event around some critical section, and then measuring the time it took between those events to figure out, okay, is that within my performance envelope? If anybody attended Hazem Shafty's talk about Visual Studio, they use instrumentation to do that same sort of thing for multi-core applications. That's just one application of the eventing infrastructure. When we think of IT pros, IT admins, they use instrumentation in similar ways, except they're trying to solve different problems. They're trying to figure out how to load balance their environments. They use instrumentation, such as the CPU counters, to look across their deployments, find out which machines are overloaded, which machines are underloaded, and deploy their software appropriately. If you raise that same sort of instrumentation from your application, they can make those decisions based on your instrumentation. The key here, and the key thing about our technologies, are that they're designed not to impact the performance of your application, whether being used or not being used. Also, we provide APIs such that if you're developing in C# or C++, it doesn't matter, we have you covered. The other thing that's key here is that you don't have to shut down the machine. You don't have to recompile your application. You don't even have to restart your application to turn on and off the instrumentation that is coming from your application. This makes it very easy to use from the consumption perspective. And lastly, it's the person who is actually consuming the data who has the ability to control where that data goes. So if I want to get data out of your application, I can choose to log it to a log file, or I can choose to look at it in real time. It's up to the person who's consuming it. You don't have to define that at the time that you write your application. So let's dig into performance counters and events. So it's really useful to think about an example here. So throughout the rest of my part of the presentation, I'm going to be talking about an example. It's an application I call all caps. It's a very simple application. The point of this application is to take a file and copy it. And while it's copying it, convert all the characters into uppercase characters. Really dead simple application. Places where I'd want to instrument this application are around the processing loops, for example. I would put a start and stop event around the larger loop that's doing the processing. If I want an example of where I would use a performance counter, I may want to take a look at the rate at which this application is copying data. So I'd put a performance counter in around the bytes per second transferred by the application. When I look at the data types between the two types of instrumentation, performance counters are strictly numerical, whereas events, they have a payload associated with them. They have message strings. You can actually format that data and present it to the user in a way that actually makes sense to a human being reading it. And lastly, the consumption story is flexible for both models. And I'm actually going to do a demo right now to actually show you what that looks like. The key here, though, is that your application can make use of both performance counters and events at the same time, and by choosing to do so appropriately, you raise the right information to help somebody solve their problems and help you as a developer solve your own problems. So let's take a look at a demo. What I'm going to demo for you today, again, is this application that I was talking about called All Caps. Now, right now, it's actually running in the background. I sent a very, very large file to it. It's just sitting there churning away. I'm going to use Windows PowerShell to show you the instrumentation that that application is raising. Now, keep in mind, PowerShell is not the only way you can get to this information. There are API sets to consume the information, and there are other utilities that are in box to consume the information. I'm showing you Windows PowerShell because this is something that is new in Windows 7. So the first thing I'm going to do is ask the system to list out all of the providers, the things that generate generate counters, that have my keyword in them. When I wrote this program, I named my provider All Caps, which is the name of my application. When I do this, the command that returns to me a set of information. In this case, counters are identified by paths, right here. What I can now do is tell the system to give me back the information associated with those paths. So now I just say get counter, and I pass it in the two paths that I'm interested in, the total number of bytes copied and the current bytes per second that the application's operating on. When I do so, I get nothing. Now the question is, did I kill the application? Oh, you know what? I didn't press enter when I started it. That's helpful. So now, if I do that, I can see the information that the application is returning. So what I see here on the left column is the total number of bytes the application has transferred. And now I can see the total bytes per second. Now, I told you this is a file copy. I've hobbled the application to run at a rate at maximum 256 bytes per second, just for demo purposes. So I didn't have to give it a very large file. And you can see here, I'm running around 250, 252. And that's just because the way that I've hobbled the application. So I can see here that rate's changing as it's operating. It allows me to surface information to somebody who didn't know anything about my application. So that's what counters look like. Now, when I look at events, I can do the same thing. I can discover the counter providers that are on the box, or the event providers that are on the box, both equally. So here, I'm going to do a search for that provider, and I find out that I have a provider called company-product-all caps. I can now ask to get the information from those logs. So the first part of this command here is just simply asking for the data. In PowerShell, I can format my data. I'm doing so because the screen's small with the large size. So if I do that, I get all the events that this application has raised since it's been running on this system. Now, I've run it several times. I ran it before I started this demo to populate the log. And what I can see here are the messages associated with that application. So I can see a success event here where it tells me that I copied one file to another. Or, for example, here's an error event where I tried to open a file that didn't exist, and the file I actually tried to open was called does not exist file, and it reported an error back to me. These are the sort of things that you can raise with events. And as we go forward, I'll talk about where the proper places are to raise events, the proper places to put in counters. So let's switch back to the presentation here. Now, with events, we have a lot of different options when it comes to events. The event infrastructure has been around for a long time. One technology, if you are a native developer that you're probably familiar with, is the Windows Trace preprocessor. WPP is a native technology, and it's very, very easy to use. The problem with WPP is that it doesn't make the events that it raises discoverable. So everything that I just did in showing you how I found the events that are on the system can't be done with WPP. And so we're not going to focus on that in this talk. But I do want to bring it up because it has its use. As for a native developer, it's useful because it is quite literally as easy as printf. And that's the ease of use that we're trying to go for here. Now, moving on, for the technologies that we have available for managed developers and for native developers, we have ETW, which is Event Tracing for Windows. ETW is a great technology because it allows me to do things that I just showed you. It allows me to write my instrumentation in XML manifests, which lets me declare what events I raise up front. So the Windows system knows that my application can raise these events, then I can in turn call APIs. I can use utilities to discover the events that that application can raise. So what I just showed you there in searching for that event provider is made possible by manifesting those events. I can also find out the entire set of events that the application can raise without the application raising them itself. So I can do some nice discoverability things there. It allows for programmatic consumption, and it makes it easy to basically highlight what my application is going to do when it's under operation. The key here is that it's a little bit more costly than writing WPP because you do actually have to write that manifest. Secondly, we have the event log. Now, many of you are probably familiar with these two technologies in one shape or form, ETW, the event log. There's a lot of confusion between them, to be honest. Now, what I want to do here is alleviate that confusion. These two technologies, in Windows Vista and beyond, are the same API set. It's the same development model. You don't have to do anything differently in terms of setting up your environment and authoring and what you do in terms of calling APIs. It's the same. The only difference between these two technologies are that the event log events are targeted at system administrators, and the goal there is that those events are always enabled. When we talk about ETW, the events are really targeted at you as a developer or an IT pro, because you have to have special knowledge. You have to know how to turn on events and turn them off. Events that are directed to the event log are just always on. So I can go to a machine, look at those events, and I don't have to do anything to enable, disable them. I can just find them. The event log also adds some extra features in terms of remote collection and in terms of doing data queries. But when it comes to the authoring experience for the developer, the only difference between the two is what I put in the manifest. And it really comes down to a couple extra lines on telling those events to be enabled always and to go to the event log. Now that we've talked about the technologies, I'm going to talk about the improvements we've made in Windows 7. The first thing I'm going to do is transition back to performance counters and talk about the improvements we made there. The first thing is that we've introduced a new API set in Windows 7. This API set is to allow you to raise natively in kernel mode performance counters using the V2 API. In Windows Vista, we introduced a new API that made it easier to write performance counters, which I'll show you today. We've just extended that into kernel mode. Secondly, as Ricky was talking about, one of the missions of our group is to basically give Windows and give you the tools to create better quality software. We've actually employed that internally, and we've done a lot of work on our own systems to actually improve the quality. Some examples here are the counter files, BLG files, which actually hold counter values. The opening and processing of them has been greatly increased. We're talking around 100 to 1,000 times faster on a Windows 7 machine compared to Windows Vista. Other improvements that we've made have been around the counters that we actually provide on the system itself. We now have counters related to doing multi-core, and we've also increased the number of we've added counters for greater than 64 processor support. The other thing that we've done is add the ability to consume the data in more flexible ways. I've showed you the PowerShell commandlet. The other thing we've done is added a couple other commandlets in PowerShell to export log files and import log files directly from the command line, making it easier to script these things out. Now, when we talk about the event log, similarly, we've made a number of quality improvements here. Some improvements we've made have been centered around the logging rates. So when we talk about one of the common questions that comes up is, well, how many cycles does it actually take to log an event? Well, I can answer that with Windows 7. We take somewhere around 3,000 to 4,000 cycles to log an event. Now, what's great about that is that when you log an event, it's non-blocking. So those 3,000, 4,000 cycles are guaranteed. You know you're not going to wait for that API to return. It's just going to go tell the system to log the event and immediately return to you, which is fantastic. The other thing we've done is improved the peak throughput by somewhere around 40%. Of course, again, your mileage may vary on your hardware, but that improvement is helping to reduce the overall impact on the system that events have on your system when they're being used. The other thing is that this is now the most instrumented version of Windows that we've released to date. Starting with Windows XP, we had around 11 event providers. In Windows Vista, when released, we had in the range of 340. Windows 7 we're releasing with 640 event providers. The improvements that we've made in terms of development are largely centered around using the manifest as a source of information to actually generate code for you. This is a great improvement. What it does is it allows me to author that XML manifest which I talked about, and then generate the code that would actually allow me to log those events in the manifest. What I can do then is actually raise events with one-line macros. Previously, before we did this, it took several lines of code to actually raise an event. Now we brought it down to a one-line call, which we'll see when I show you some code later. We've also improved some design time validation things. We've done this for performance counters as well. Authoring XML by hand is difficult sometimes. The design time validation that we do through our processing tools now actually informs you earlier in your design cycle when you've introduced an error, introduced a problem into your XML. So that it's easier to actually get this right when you write your code. And then we've made improvements along the lines of event consumption. We've improved the speed at which our real-time consumers work. We have improved the ability to open and process event files. Some of our tools actually work twice as fast now on Windows 7. We've also added the ability to portably decode event files. So if I log a set of events on a Windows Vista machine, and actually transfer that file over to a Windows 7 machine and view those events without losing any data. The other thing is we've improved the data formatting. So if you remember before when I showed you the example in Windows PowerShell, I showed you an example of an event that told me that I had an error when I tried to open a file. What I actually logged when I logged that event wasn't the string that said the file already exists. I actually just logged the error code. Now what we do when you raise an event, if you've tagged it appropriately with the proper out type is what we call it, the system will translate that error code in the proper status message and print that for the user, making it much easier for an admin to actually consume those events and make sense of them, and saving your time and so that you don't have to actually convert those error codes to strings. Another set of improvements that we've made have been centered around the Windows Performance Toolkits. I don't have time to go into that, but they're very interesting, and we've actually recorded some talks that will be available to you on MSDN that you'll be able to go and view, so I encourage you to check that out. We'll have references to those at the end of this deck. So now we've talked about what instrumentation is. We've talked about the improvements we made in Windows 7. Now let's actually take a look at how we actually design instrumentation. So instrumentation design is very critical. If you don't write your events in a way that somebody can actually consume them, if you don't write them in a way that they're useful to somebody, whether that's you yourself, somebody else on your development team in your own company, or somebody who is an IT admin trying to work with your software, they're kind of useless. So we want to encourage you to think about who's going to consume your events. Now it's difficult to give advice here because you know your applications, we don't. But this is a process that we go through. We look at the events that we raise in Windows and try to make sure that we're doing the right thing. So that you, who are not familiar with our software, or maybe you are very familiar with our software, but you can look at it and figure out what's going on under the hood in a way that is meaningful for you to solve problems. The other thing is that we encourage you to use the recommended interfaces. On Vista Forward, we have a new set of APIs that we use for performance counters and events. If you have no need to go down level, we encourage you to use these APIs. Now, the code generation that I talked about will actually generate down-level code for you, which is a huge win for the events. But with performance counters, there's no such analog, and so we encourage you to use these APIs. I won't go into these APIs. They're here for reference. I'll show you an example of them in native code when I go through the example. The key is that you want to design your events with a goal in mind. So always keep that around. It's easy to get lost in the muck and the mire when you're actually going to code your events, but you need to step up and think about who's going to consume them at the time that you release your application. So let's talk about design. So we just talked about design. After you've got that design in your head, what you want to raise, the next step is actually to author your XML. Now, when I author the XML, we have tools that are going to be released in the final SDK that help you do that. It's a tool called ECManGen, which will hopefully make that process easier. But you can go today and write your XML by hand to author your events, and we'll show you how that works. After you have generated your XML manifest, which tells the system essentially what instrumentation you're going to raise, you can then generate code. The code generation is done by two tools. In the case of counters, we use CTRPP, which is short for counter preprocessor. And then we have a tool called MC, which is short for message compiler. MC is what processes the event files to create the code for events. From that, we generate resources. We generate header files for you, which can be included in your project. This is where we've made a lot of our improvements in Windows 7 in terms of the authoring experience. This is what generates the macros for you to log events. This is what generates the code for you to actually log your performance counters. The next step is to actually instrument your code. So those places where you want to raise events, you actually have to put code in there to say where you want to raise them. What's useful here is that you include the header file that we've generated for you, which has the macros, which has the predefines, that you can use to make this a lot easier. Then, of course, the last step is actually build and run your project. So let's take a look at what it actually means to write code and put this all together. So I'm going to go back to the application that I talked about earlier, this all caps program. Now, I've already wrote my manifest. I've already generated those header files, which is the first step. And I've included those here in my project. So this is the file that's generated by CTRPP. This is one generated by MC. Now, if I take a look at this application, it's pretty simple. All I do is put a source file and a destination file, and it does its work. The first thing that I have to do for my event provider is actually register it. Now here, it's a one-line call. When I define my manifest, I declare that my provider is called this, and so this was the code that was generated for me. Similarly, I have a counter initialize function which is generated for me for my counters. I have to do the registration because this is how my application notifies the system that the application is going to try to raise events and try to raise counters. It's basically the hello world, I'm here, come and get data from me if anybody asks for it. Now I'm going to go through this and look at the events first. So the first thing I want to do is look at the place where I actually open the existing file as an example. In this case, I call the create file function, and I'm trying to open an existing file. And sometimes that can fail. Now, whereas before, I would actually do a printf here in my application saying, oh, this is where something failed, and I'd return a code. Now, instead, I write out a one-line macro. This one-line macro is the thing that actually goes and raises that event when I run the code. If you take a look at the manifest file for this, this is actually the event that's declared that raises that event. And so here you can see this is where I actually named it, which is where the macro got its name. And I have a bunch of other information here about that event that I don't really have time to go into. But it has things like the level at which this event is being raised at. Meaning, is it critical? Is it a warning? Is it just an informational thing? And I also tell it where I want it to go. In this case, I'm giving it this channel. Events have templates to them as well. Those templates basically dictate what data, what's in the payload of that event. If I take a look at the payload for this, I see that I have both a Unicode string, which is the file name, and I have the error that's being raised, which is the out type here being Win32 error. What I talked about before with PowerShell, this is what actually generates this. Because I declared that piece of data as being an error, that's how I actually got the system to generate this string instead of just the error code that was generated. Now this string is actually in a string section at the bottom of the manifest. I won't show you that, but basically it just defines the string, and you use %1, %2 to indicate which fields you want to have filled in there. So that's what the manifest looks like. And again, when I raise events, I just do one-line macros. Now, I talked about ETW and the event log. The event log is always on. So when I encounter this event, it's always going to write out to the event log. There are other events that I want to raise, but I don't want them to be visible to the admin all the time. In this case, I have an event here where I want to wrap around my do while loop that says, this is where I'm starting the copy, and correspondingly I have an event at the bottom that says this is where I'm stopping the copy. This is the event that I'm going to try to use to actually gauge my performance of this loop. So I put the start event and the stop event. Now, this macro was generated the same way as the other macro that I just showed you. There's a corresponding template with it, which actually is blank because I don't need to carry any data with this event. But it defines where that event should go. And what I've done with this event is just say that it should go a place that's not enabled by default. So in order to raise my events to these two different places, I don't have to do anything different in terms of my code process. It's just I declare something in the manifest that says this isn't going to the same place those other events are. So with that, I'm going to take a look at the performance counters. Performance counters are very similar in that I have to do the registration, and then I have to declare in my code how I want them to be raised. So the first thing I have to do is actually create an instance, which is basically a set of counters that are going to be raised. I say that this application has an instance of these counters, and they're grouped together, and that's how I find them. The next thing I do is actually declare the reference values that I want to use for this counter. This is one way in which I can actually put data out. What I'm doing here is saying that this bytes per second is the actual variable that I want the performance counter system to look up when I'm actually asking for data. So when I ran that application that said, hey, give me the bytes per second, it's actually coming to my application and looking directly at that pointer location. So all I have to do in the loop that's actually processing my code is update that variable. So that kind of gives you a feel for what it takes to actually author a provider, author both an event provider and a counter provider. Unfortunately, we don't have a lot of time to go through the real muck and mire details of it, but we'd love to talk to you about it more. And there's more information available on MSDN and the like. So now that we've gone through that, there is a lot of information that's available inside of Windows for somebody who's trying to manage the Windows platform. There's registry values, there's WMI objects, and of course there's instrumentation. The question is, how do I use that information to actually troubleshoot and resolve problems? So there are ways that IT admins, IT pros use it on a regular basis. But the question is, how does an end user use it? And how does an IT pro, or how do you, as somebody who's deploying software, use that information in an automatic way, in a standardized way, so that users can resolve problems without involving us as developers directly? So that's what Ricky's going to talk about with the troubleshooting platform.
Great. Thank you, Kevin. So as Kevin just mentioned, I will be talking about the Windows troubleshooting platform, which we are newly introducing for Windows 7. So I thought I would begin by talking about how users troubleshoot problems in software and really for any technological device that they may have. And unfortunately, it tends to be a fairly manual process. They may look at help documentation or the actual manual, if they can find the manual, because if they're like me, then the one time that they actually need that manual is when they cannot find it. Or they may search online. But the process is essentially the same. They're trying to observe some sort of symptoms and translate that to what they understand and put it out and either search for the relevant help topic or search online for it. Well, it's pretty obvious. Well, what benefit do we gain if we actually automate that process? Well, clearly the user doesn't spend nearly as much time trying to solve the problem. They can go about what they were doing before. And from a support standpoint, we can reduce the amount of time we actually spend on the phone with customers. So let me give an example here. We worked pretty closely with Windows support to automate the troubleshooting of certain problems that users had. And what we found out was that for the problems whose resolutions we automated, not only did we see a statistically significant uptick in customer satisfaction, but for one particular problem, we actually reduced the amount of time that a customer support professional spent on the phone with the customer by 50%. So for that one problem, we actually reduced our overall support cost by several $100,000. So clearly the benefits are there. And now we want to translate that in Windows 7 to a broader audience. So we looked at what types of problems were users experiencing. And I go back to what I mentioned earlier. We have the design issues, and we have the configuration conflicts. And looking at the support data for Windows, we found that a lot of people were actually having configuration problems. They weren't really code bugs with Windows itself. And so we thought, that's a good target to go after. Because if we create a standard way to address configuration conflicts, we can reduce a lot of the support volume that we were having. So when we look at how do we actually address configuration conflicts, it's really a two-step process. The first is, do we actually have all the right pieces in place? If the user wants to play a video file, do we have a sound card? because it's a non-starter if we don't. And we have seen cases where a user is trying to do something and they just don't have the relevant hardware. Now that we've established that we have the right pieces, we move to the second step. Is it in the right state? Do we have an audio driver installed? Is the volume at the appropriate level? So we check all these settings to make sure that we can actually do what the user wants to do. So to consolidate that and automate that in Windows 7, we basically said, let's create something called a troubleshooting pack. And so when a user has a problem with their system, they can find the corresponding troubleshooting pack and launch it. And that troubleshooting pack will then run, detect, and resolve the configuration problems that they may be experiencing. So with that, I'll show you a snazzy demo that we have highlighting the troubleshooting pack, a Windows troubleshooting pack, to be more specific. So I'm actually I'm a big fan of action movies. And when I saw the sample video, Windows Vista, I was floored. This is good stuff. And so I brought Kevin over and I said, Kevin, look at this. But there's a problem. There's no sound. So let's put the hat on of the user and say, what would a user do to try and troubleshoot the sound problem? Well, they would probably go to help and support. So that's what I've done here. I've created a help and support. If I can find it, there we go. And I search for no sound. And so I see this thing for tips for fixing common sound problems. That sounds pretty promising. So let me click on that. And this brings up several categories. So there's this first one here that says, I can't hear a sound from my computer. That's right. Now, remember, we're thinking here in terms of the normal user, who may not necessarily be that technically savvy. Now, I apologize, the font is a little small, but if you look at the form, there's a bunch of links, there's some stuff in bold, there's some shields. At this point, I'm basically lost. And if you read through it, it asks you to check all sorts of settings and launch device manager and otherwise contact your hardware manufacturer. We don't really want to leave them hanging. So with Windows 7, though, we can actually troubleshoot this automatically. So I'll come here to the the speaker icon in the lower right and click on that. And what this is actually doing is this is launching our audio troubleshooting pack. So it brings up a wizard that says, troubleshoot your computer problems for Play Sound. The publisher is Microsoft. I trust them. So I'll go ahead and click Begin. Now what this is doing is essentially the steps I mentioned earlier. It's looking at all the configuration settings that are required to play sound on the system. And it's checking to make sure that we have the right pieces in place. And if we do have the right pieces in place, are they in the right state? Now, in this particular instance, the setting that is not correct is that the audio service is not running. And if you were to read the help topic, that's not something that's necessarily surfaced initially. So a lot of users would be at a loss if they didn't realize that the audio service is not running. And so what we're doing here is we're just, I have a slow machine. We're checking the service status. And in this case, we actually automatically turned it on. And we now hear the beautiful sounds of nature coming through the speakers. So without doing anything, I just clicked one button. And it went through and it checked everything for me. And here it's checking some other settings, making sure my volume is OK. And here, yes, the problem's been fixed. And so I can go ahead and move on from there. So that was what we call the wizard UI for troubleshooting packs. And if we look at some of the key features of those troubleshooting packs, well, we just saw that it was pretty easy to discover. I just clicked on the sound icon, and it brought up my troubleshooting pack. I didn't have to do anything else. And the nice thing about these troubleshooting packs is I can actually link to them from my help documentation. So one of the things we are looking at in Windows 7 is to link the Windows troubleshooting packs to the corresponding help topics. So instead of reading all that text for solving audio problems, there will actually be a link to launch that troubleshooting pack from that help topic. So that user can then, with one click, solve their audio problem. Now, once the user has found that troubleshooting pack, we saw it was pretty easy to execute. They clicked one button, it ran through, it solved it. There was no other interaction required. Now, the other nice thing about this is that each Windows troubleshooting pack, and for that matter, any troubleshooting pack, can share the same experience. That wizard UI will be shared by both our audio troubleshooting pack, our video troubleshooting pack, and our networking troubleshooting pack. So regardless of what problem the user is trying to solve, they all look the same. So there's a sense of familiarity there. And finally, we have that certificate. I mentioned there was a publisher there, which had Microsoft Corporation. So that each troubleshooting pack is signed. It's not really just some random files that I downloaded and I'm running. So user has an ability to essentially make a trust decision before they run a troubleshooting pack to alter state on their system. So these are the features from the user standpoint. But as we were designing this platform, we realized that there are a lot of benefits for the admin here as well. An admin is tasked with managing multiple machines. And any of those machines could have configuration problems. So why not extend this benefit to administrators? So when I mentioned that a troubleshooting pack is actually a problem, an executable, it's not quite true. It's actually a cab file. So this single file, if I double-click it, can actually run that troubleshooting wizard. So now you can imagine an administrator can basically post these cab files on an internal share or an internal website, help website. And a user can basically be directed there, click on that, and run a troubleshooting pack. And actually what we're doing for internal Microsoft IT deployments is that. We have an internal help website, and we're looking to put troubleshooting packs on that help website. So any of our thousands of clients can actually go to that help website, click on a link, and then launch a troubleshooting pack. Now, that's for clients actually launching that. There's also the admin running a troubleshooting pack. And so we saw the UI way of doing it. There's actually a command line way of running that troubleshooting pack. Through Windows PowerShell, we can actually run these troubleshooting packs in unattended mode. And we can actually leverage the Windows, PowerShell remote run space to actually run these remotely on multiple machines. So now you can imagine I have 500 different machines, and I want to make sure that they're in the right state. I can do that by using our troubleshooting pack and the PowerShell remote run space to deploy these troubleshooting packs on 500 different machines and run them. Now, of course, there's also the security aspect of it, but we went one step further. And we said, you know what, there are cases where an administrator may only want selected troubleshooting packs to run. And so the way we do this is there's a group policy bit that controls which publishers can actually run. So in the Trusted Publisher Store, you can store a certificate from Publisher X. And if that group policy bit is set, then only those publishers that are signed with that certificate for Publisher X will actually run on the system. So now in an internal corporate environment, you can imagine an administrator basically saying, I will only run troubleshooting packs from Microsoft and from my internal corporate deployment. And they can do so by actually turning on this group policy bit and storing those two certificates in the Trusted Publisher Store. So let's take a look at running a troubleshooting pack from Windows PowerShell. So I'm going to come back here to my demo. I don't want to deprive you all of the video, so I'll keep that playing. And I'm going to come here to Windows PowerShell. So we actually have two commandlets that run troubleshooting packs. The first is get diag pack. And what get diag pack does is essentially returns information about a troubleshooting pack. This is essentially similar to the initial screen we saw when we launched the audio troubleshooting pack. And so in this case, I'm back in the same state. I don't have sound. I will admit this is somewhat of a trivial scenario because I did mute the sound before. But let's forget that and say, oh, you know what, I don't know what's going on. So what I'm doing is I just want to find out information about a troubleshooting pack. Now, all the Windows troubleshooting packs are stored in the system folder under Diagnostics. So what I'm doing here is I'm just using get diag pack to retrieve some information and using format table to actually display some information about it. And this returns back saying that there is an ID audio diagnostic. The name of the troubleshooting pack is sound. This sounds promising. So what I can then do is take that object that is returned from get diag pack and pass it to invoke diag pack. And invoke diag pack is what actually runs the troubleshooting pack. In this case, I've decided to run the troubleshooting pack in interactive mode locally on my machine. And here it asks a question. So, well, I'd like to troubleshoot speakers. So I'll go ahead and hit 1 and then enter. And now this is essentially running the troubleshooting process for detecting problems with speakers. In this case, it will come back and say that my device is muted. and it will give me what we call a root cause, or one particular configuration problem that is causing sound to not play. Now that one particular configuration setting may have multiple ways of solving it. In this case, there's only one way of solving it, which is to unmute the audio. And so I'll say, OK, I'll unmute the audio. Now, this is resolving that problem, and I get my sound back. So let me go ahead and stop this. And then what I can do is exit out of Windows PowerShell, and we solved our problem. So that is essentially the command line way of running that same exact troubleshooting pack that we saw the UI of. Back here. Now, we've seen sort of the user aspect of it, a user running it, a system administrator running it. How do we develop these things? Well, we wanted to make sure that it was as easy to develop as possible. And so if we have a PowerShell way of running these troubleshooting packs, why not actually have them just be PowerShell scripts? And so really, these troubleshooting packs are basically just a collection of PowerShell scripts. The phases of detection, resolution, and verification are all done through PowerShell scripts. Now, even the user input is actually captured through PowerShell. So when we ran that audio troubleshooting pack through PowerShell, we saw that question that was being asked. There was no fancy code around that. It was essentially one function call in PowerShell asking the platform to say, ask the user this question, and send me back the answer. Now, because these are basically just PowerShell scripts that are combined into a cab file, it's very easy to deploy with your application. Now, we understand that it may be necessary to debug these things, because the worst case would be a troubleshooting pack that tries to fix a problem that actually has a problem. And so what we did is we added something called a debug report. So as this troubleshooting pack is running, all the information, such as errors and exceptions that are caught by the PowerShell scripts, are stored in this debug report. The other nice thing about the debug report is that it has additional information about the performance of the troubleshooting pack, such as how long it took to initialize, or how long this particular script took to run. And so that way we can actually tweak and optimize things to make sure that in the simplest case, it runs as fast as possible. And of course, this thing is signed by a certificate. If that hasn't been drilled in your head by now, you have some issues. So now that we've seen a troubleshooting pack, let's look a little bit at the architecture. So the troubleshooting pack actually consists of not only the script files, but some metadata. The metadata describes that troubleshooting pack. Now that pack actually runs on the platform. Now platform is what instantiates its own PowerShell runtime. So the commandlets that you use to actually create these things are not discoverable through PowerShell.exe, because we actually create our own runtime to execute these troubleshooting packs. Now it's that platform that acts as a mediator between the executing pack and the UI and the command line. So these packs don't actually code UI. They don't code the command line interfaces. The platform essentially does that for them. Now, as those packs are executing, the reports are generated. The first report I mentioned was what we call the debug report. Now, there is also an administrator report. So if we think the user is actually trying to run these troubleshooting packs to solve their problem, and there are cases where they may not do so, and so they have to call support or help desk. Now, what a help desk or support technician can do is actually look at the administrative reports to see what troubleshooting packs the user tried to run and what configuration problems were found or not found. So that at least gives them some context in which they can actually scope their discussion. So let's dive a little deeper into the troubleshooting pack. What does this thing contain? So I mentioned the metadata. The metadata is basically an XML file. And this XML file contains the name, description of the troubleshooting pack. It has a security signature. And it also has the specific configuration issues that troubleshooting pack can find. So in the audio case, we found two. One that the device was muted, and that the audio service was not running. So each of those is actually statically declared in the metadata. And we'll see that in a little bit later in the authoring section, how we actually add these things into the troubleshooting pack. We have the detection scripts, which will essentially find one of the configuration problems that was isolated in that metadata. The resolution scripts. The verification scripts, which actually run after we run the resolution scripts to see, have we actually solved the problem? And finally, the localized resources. So all the strings that we saw in the UI and in the PowerShell command line are localizable through the MUI support and also through the PowerShell localization support. So now that we have these different pieces, how do they actually interact with the platform? So the first thing we did is I clicked that sound icon, and it brought up the initial splash screen. what was happening there was that the platform was actually taking the identification metadata, parsing that XML file, looking at the localized resources, and displaying it up through the UI or the command line. Now, the reason this is actually separate is because as a developer, you can choose not to use the default Windows wizard. You can actually create your own experience around a troubleshooting pack, and that platform will interact with your own UI. In this case, it happens to be the wizard or the command line, and so the user then clicks Begin. So the user is now consenting to running that troubleshooting pack. And the other thing I want to mention here, too, is that as we're doing this, we're actually validating the integrity of the pack with that signature. So we can now check to see have files been tampered, are they missing, is the hash incorrect. So I click Begin. The platform takes the detection scripts, and it creates the PowerShell runtime, and it passes it in. Now, there are 4 cases where that executing script will communicate back to the platform. The first is it lets the platform know, hey, I found this configuration problem. And since the platform knows what configuration problems it can find, it can basically communicate that up to the UI or the command line. The second one is get input from the user. We saw that with the audio PowerShell commandlet, where it asked, what device do you want to troubleshoot? There's the provide progress. We saw the progress statements fly by. And finally, write information to the report. So thus far, I've only said that the platform is writing information to the report. But the scripts can actually add additional information. So WMI objects, registry keys, events or performance counters, all that information can be directed to a report. So now you have this rich context available when you analyze this stuff afterwards to understand if your troubleshooting pack didn't solve the problem, what was the state of the machine when I ran the troubleshooting pack so that I can make improvements and then address those problems in the future. Now, once we actually have the list of configuration problems we can find, we run the resolution scripts and the verification scripts. And that's sort of the interaction between the pack and the platform. So how do we author these things? Well, the first thing we do is, of course, isolate what exactly are we going to find? What problems are we going to find? Once we have that, we write the corresponding troubleshooting, resolution, and verification scripts. Now, to do that, we've created something called the Windows Troubleshooting Toolkit. The toolkit is basically a design environment in which you can actually create these troubleshooting packs. There's a link to graphical PowerShell, so you can author your troubleshooting packs in that same environment. Now, what that tool does is with one click, I can basically build that troubleshooting pack and then create a cab file that I can then deploy. So let's take a look at this troubleshooting toolkit. Now, keep in mind that this is essentially a pre-beta build, so things are in flux. And this tool will actually be available as part of the software development kit when Windows 7 releases. So I'm going to come here, and this is essentially a very simple UI. And so what we'll do here is we'll actually create a very simple audio troubleshooting pack. Well, there are many reasons why audio won't work. Here we'll just do the first one we found, which is the audio service is not running. So I have a name here, audio service is not running. I give it an ID. This is essentially a URI. And that has an associated description. And both the name and the description can be localized through MUI support or through the PowerShell support. Now, to find this particular configuration, we have a troubleshooting script. And that's linked here. There's only one troubleshooting script in this particular troubleshooting pack. There can actually be multiple troubleshooting scripts. So if I were to click this Launch Script Editor, that would actually launch Graphical PowerShell, which I've already sort of done here. And this is our PowerShell script to actually troubleshoot the audio problem. The first statement is what we call write diag progress. So that progress statement that we're seeing in the UI is actually done by calling this particular function. And here all I'm saying is my activity is detecting audio service. Notice, again, there's no UI anything here. I'm just saying write diag progress, here's my statement. I don't normally recommend sleep, but for this particular case, I have it in here so we can actually see that progress statement. Now, to find whether or not the service is running, I call get service. Get service is basically a command that you can run in PowerShell.exe. I check its status. If it's not running, I call add diag root cause. This is basically telling the platform I found this particular configuration issue. And we note that it's actually passing back the ID. So if we go back here, we notice that it's the same ID that references this particular root cause. Now, there's one fix in this case, which is to run the resolution script. So I can go ahead and call restart the audio service. In this case, there's an ID, fix audio service, and associated description. Now, there are a few other attributes here that I won't get into too much detail, But basically, there are some cases where you may want to ask the user whether or not they actually want to follow through on it. An example is with transparency. We see the glass effects here. That doesn't work if you're running in power saver mode. So if the user is trying to get transparency back, you need to ask them first, do you actually want to go from power saver mode to balance mode? So that's done by clicking that requires consent to yes. And of course, certain things may require elevation. In this case, restarting a service is a privileged operation, and so our script does require elevation. There are cases where you can resolve the problem without elevating, and in those cases, a standard user can actually run a troubleshooting pack to solve their problem. So again, if I click Launch Script Editor here, it launches Graphical PowerShell, and this is a very simple resolution script. Here we're saying the progress is restarting audio service, we sleep for 2 seconds, and we start the service. So what I can do with this troubleshooting toolkit actually is go to the build menu here and hit run. And what this is doing is this is compiling my troubleshooting pack. It's signing it. It's creating up a cab file. And I can actually run it and test it in here in this environment. So this will bring up that UI wizard that we saw with the audio pack. Again, it was like basically 2 scripts, 6 lines of code, and I have a complete UI experience around it. Now, just to show you that it actually is a cab file, I'll come here to the output directory. And we have the default name here, Diag package. If I double click on this Diag package, it actually brings up that same UI wizard. So we can imagine here I can take that file, I can copy it somewhere, I can put it on a share, and I can now direct people to that location so that they can now resolve their problems. Now, when I ran the UI earlier, I did it in what we call the standard user mode, which is a single click, let's solve the problem. Now, we do have an equivalent PowerShell mode, if you will, which is where we actually tell the user, this is what we found. So let me first stop the service. So we're now stopping the audio service. And we can see that in the lower right corner, the speaker icon is now changed to the red X. Now come back here, and I'll run this in what we call the advanced flow. So we see here our progress statement detecting audio service status, and it comes back with the service is not running. And this is essentially our root cause name and description. And I can choose to select or unselect and selectively fix different configuration problems. In this case, there's only one, so I'll go ahead and click Fix. And we see that the icon now changes on the lower right. So click Next here, and then yes, the problem has been fixed. So right there with the toolkit, we very easily built this troubleshooting pack. Now there's one more thing I want to show, which is the identification metadata. So I mentioned earlier that it is basically an XML file. And with this toolkit, you can actually come here and click on the actual in the view here to actually generate the XML file. Now that's pretty small, so I'm going to bring up VS here to show you the XML file. Now there's really 3 main areas that I'm going to call out here. One is the troubleshooter section. Then there's the resolution section and the verification section. So in this case, all the attributes that we saw in the UI is written here in the XML. Here's our link to our here's the link to our troubleshooting script. In this case, it doesn't require any elevation, and it runs on any processor architecture. Now, there's a list of root causes or configuration problems that that script can find. Here we only have one, which is the audio service is not running. And we have links here to our localized resources. There can be multiple resolvers for a single configuration problem. Here again, we only have one, which is fixed audio service. And as a link to the script element, we call it, which is the actual link to the resolver script. And finally, we have the verification phase. I didn't actually show the verification phase, but in this case, it's actually a link to it's a link to the troubleshooting script. Because if we think about it, the actual process of detecting whether or not the service is running is the same way we can verify that it's actually running. And so in this case, we actually link back to the same troubleshooter script. And so with that, it's possible to actually generate this XML by hand. But now that we have a fancy UI around it, I suggest that you use that to actually develop these troubleshooting packs. So I come here, and let's talk about deployment. How do we actually deploy these things? We built it, we generated a cab file. So what will Windows do? Well, when we ship Windows 7, we will have critical inbox troubleshooting packs for networking, for audio, for video, sort of the basic functionality of the system. Now, we understand that we can't actually foresee all problems that we will encounter. And so what we will do is we have this thing called the online troubleshooting service. And so after Windows 7 ships, if we need to react to new problems, we can post troubleshooting packs on this online service. And in addition to that, we can actually target machines through this service. So I can now say, you know what, this pack only works for x86 architecture. So it will only go to those users that are actually running x86. Now, how can you leverage this platform? Well, I mentioned it's basically just a file. And so you can ship this file with your application and simply have a launch point in your UI to allow the user to run that troubleshooting pack. You can post this online. If you have an online help topic or website, you simply put a link there, just as we're doing internally, and have a user launch that troubleshooting pack. And of course, your help documentation. Windows will have links to certain troubleshooting packs from its own help documentation when Windows 7 ships, and you can do that as well. The key thing here is that there are multiple deployment options available to you to actually use and deploy these troubleshooting packs. So with that, I will hand it back off to Kevin.
Oh, thank you, Ricky. So we spent a lot of time talking about software problems today from two different angles. One, what you can do as a developer to add code, add instrumentation to your applications to help you during development resolve problems, and to help the people who are deploying your applications solve their problems. We've also talked about the troubleshooting environment and how you can leverage that to help your users solve their problems after your application's been deployed. These tools allow us to create an ecosystem that's standardized, which helps us all solve our problems in the easiest way possible. Consistency is the key here. And so what I want to emphasize here is what you can do walking out of here. What are the call to actions here? The first thing is that we encourage you to review and revise your existing debugging techniques and see where instrumentation can actually be leveraged in your environments. And to that end, to add and upgrade your instrumentation with appropriate technology. With respect to troubleshooting, we encourage you to go to MSDN, where we will be posting a white paper describing everything that Ricky just talked about with respect to the troubleshooting platform in even more detail. And of course, when you read that and as you're walking out of here, we want you to start thinking about how you can deploy troubleshooting packs to help your users and help yourself solve problems. There's also a lot of related content to what we do in terms of our team's mission. There are several sessions which have been recorded and will be available on MSDN for you to download and take a look at. I encourage you to take a look at these sessions. They will help you understand how we're filling out the rest of our story from the fundamentals perspective in terms of how we're encouraging you to look at our tools and how to improve your performance and debug and resolve your own issues with your applications. And we'll also be at a booth in the big room that you can come and talk to us about the technologies we've just talked about. So with that, of course, is the standard plug to fill out your evaluation forms, and that you can, of course, see this video online if you need to see this deck again. And with that, I'll open the floor for questions. If you could, please use the microphone. And thank you for coming.